Good morning, everyone, and welcome to this second STS live stream. So for those who haven't been able to attend the first live session STS, my name is Kevin Faber. I'm the sales engineer for STS products in the UK and Ireland. And today I'm here with Terry Mish, my colleague Terry Mish here.
Hi, thank you, Kevin. Good to be here. So I'm Terry Mish of Socomec, working in the technical department. And also be keeping an eye on the chat as well. So if you have any comments and questions, just chuck them in and I'll try and get hold of them. So yeah, cheers, Kevin. So let's go. How do we choose the right STS for our application?
So thank you for this question, Terry. Actually, as you may all know, it can be kind of tricky when you arrive at the point of choosing the right STS for your application. So on the market, you can find for three-phase products, 3-wire, 3-pole switching, 4-wire, 3-pole switching, 4-wire, 4-pole switching. Very confusing for everyone. So it's really important to understand the way it works and when it arrives to choosing the right one, either being in touch with us or just trying to understand it your way, to make sure you wouldn't make any mistake.
Yeah, and it's important for us to have that information from the get-go because the machines are slightly different inside. Internally, they're wired differently. So, you know, the 3 and 4 wire, especially different power supply setup. So it's quite important we get that right from the beginning to make sure it's a smooth installation there.
100%, yeah. And a really key point which is really important to understand is the earth and neutral system installed in your application. So as you probably know, there are like 3-4 main earth and neutral systems. So let's start with the first one, which is TNS. So with the TNS earth and neutral system, you would get a separate earth and neutral conductors, and you would get the equipment earth straight to the source. So you probably have heard about the TNC1 as well, which is a different type of earth and neutral system, which basically would get the same thing, but you would only get a same conductor for the earth and neutral. So they are connected together, and you would get a PEN conductor. Another one which is very common as well is probably the one you've got at home actually, it's a TT earth and neutral system. So for this one, you would get the equipment earthed locally. So you would get an independent earth local close to the equipment. And the third one that is quite important and very famous in a medical environment, for example, is the IT earth and neutral system. So as you can see, you would get a specific device that would monitor the current, and you would get the equipment earthed locally as well.
Yeah, it's quite nice there especially when you talk about medical environment, so you don't want to have somebody accidentally plug something into an intensive care unit and accidentally trip off the power there. So yeah, as Kev said, we monitor, although it's monitored locally, and obviously hopefully to avoid nuisance tripping.
100%. So now we've seen all these kind of different earth and neutral systems. So as we can see here, we would recommend most of the cases to go for a 4-pole switching device. And the reason is only because you want to avoid any uncontrolled current circulating through both neutrals coming from 2 sources. So that's the reason where you would go with a 4-pole device. Only on the TNC, so I think, Terry, you can say a word about that with the 3-pole switching device?
Yeah, so the 3-pole switching device is when you can't interrupt that earth-neutral link. So if you just can't do it at all, so depending on the setup. So the TNC is not as common, but it is there. So again, we need to know, is it just a 3-pole that you're looking to switch? If it's 4-pole, then you could inadvertently open and break that neutral earth bond.
Correct. That's great. Thank you, Terry. Now let's understand a bit more on how it's made internally, the 3-pole device and the 4-pole switching device. As you can see on the left, you've got a 3-pole switching device. It means that basically you wouldn't have the SCR, so the component that will allow the switching from one supply to the other one. It wouldn't be fitted on the neutral. It means that if you go for a 3-pole switching, you would get the neutral connected together to the load. Rather than on a 4-pole switching device, you would get this SCR device fitted on the neutral as well. So in case of any problem on the source 1, on the primary source, you would switch the neutral from the source 1 to the alternative source. Let's have a look now at different kind of applications. So if we have a look at this first one, you can assume that you get a motor load, for example. If you have a look at the upstream, what have we got? We've got only one main supply coming from one transformer. So you've got your three-phase and neutral serving two different UPS systems. So you want to allow some more reliability for your load. So you would include an STS downstream the two UPS supplies. And as you can see here, because you've got a motor load, so you don't need the neutral for the load, it's only a three-phase motor, you would only get a three-wire, three-pole device. It means that you wouldn't connect the neutral from the supply to the STS. You would only connect the three-phase, and same on the output of the STS.
Just to pick up there on the motor load you've got, if we know that most of the load is a motor-based load, then we have a particular setting within the STS that we input when we commission, so that we can manage the load better and make sure that any regenerative current when you're doing that transfer is managed by the static switch, and you don't get any, again, nuisance tripping of the input supplies.
Correct. Another application here is with two different main supplies. So let's say you've got a supply A, three-phase and neutral. Then another supply, let's say supply B, three-phase and neutral as well. And both supplies are serving two different UPS systems. UPS A, we can imagine, let's say it's in a data center environment, for example, where you would get UPS A system and UPS B system. Both redundant, you would get two UPS on the A1 and two UPS on the AB. And then you get an STS downstream. So you've got two different supplies, but you decide to, let's say you want to save some cost on the neutral conductor, for example. You want to go with a downstream transformer. So in that case, again, you can go with a three-wire, three-pole device, and then your downstream transformer will allow you to recreate a proper neutral for your load.
So yeah, as Kevin mentioned there, you're saving a bit of money in not running that extra conductor. And once again, the same with the motor load, we have settings within the static switch to manage the transformer as well. So we make sure, again, we're avoiding any inrush currents and nuisance tripping when we're carrying out transfer. So again, it's important at commissioning stage that we know there's a transformer or a motor or whatever the load is, so we can manage it properly.
Nice one, thanks for the comment. Here's another application where you would get on the upstream one main supply, so three-phase and neutral, serving the two UPS systems. So again, we can assume it's a data center environment with UPS A and UPS B. Both are redundant independently. An ACS card for the synchronization, and only one common main supply serving these two UPS systems. You can assume that downstream you would get some IT equipment, so some racks that would need the neutral. So in that case, you can go with a four-wire, three-pole device because you would need the neutral. Upstream, you would get only one neutral. So in this specific example, you can reconnect the neutral together for your load.
Yeah, and it's important to point out there that it is reconnected directly at the STS input side, so it's taken in and taken back out to your load. So if in the future you changed and wanted to split that system, you may have to look at adjusting the STS to suit the application better.
Yeah, absolutely. And here's the fourth and last example, where, as you can see, you would get two different supplies. So supply A and supply B serving two different UPS systems. And downstream, you would get, for example, IT equipment, again, where you would need a three-phase and neutral. In this specific case, it's really important to go with a four-wire, four-pole device because you need to switch the neutral. You cannot get two different neutral coming from two different transformers reconnected together. You would create a massive loop and you would get uncontrolled current going through these both neutrals. You would get lots of trouble on site and you don't want that. So in that case, two different main supplies need a neutral downstream the STS. So you have to go with a four-wire, four-pole device STS.
Yeah, as Kevin said, you don't want any nuisance tripping and circulating currents and things. So yeah, certainly want to keep them separate. And then also we've shown on each of these diagrams the ACS, the cross synchronization between the UPS system. I just wanted to point out that actually with our static switches, if you lose the ACS, if one system's down for maintenance for whatever reason, then we can carry out asynchronous transfer, and the STS won't even bat an eyelid at that.
Absolutely. Just to put a little comment on this, we can hear sometimes that it's faster with a synchronized source on the input of the STS, but the STS can perform unsynchronized transfer as well. It would be slightly longer, so with, let's say, up to 10 milliseconds with this kind of device.
Still well within our 20 milliseconds. So
100%.
Yeah.
And that's the key point. So now we've understood a little bit more on the 3-pole and 4-pole device STS. Let's understand a little bit more about the cabinet version and the chassis mountable or OEM version. So here's the example of the cabinet version. So as you can see, it's a proper standalone unit. And inside, you can see you've got the STS, so the proper STS device that will allow to monitor the whole input and output around the STS unit. Inside, you would get the SCRs, of course. You would get the fans. You would get the power supplies, and all you need to manage actually this system. And around that, you would get the switchgear equipment. So you can see you would get the input switches, so one for each source, one output switch, and both bypass switches, one for each source. So if we go into a little bit more details with a single light diagram for this cabinet system, again, as we can see, we've got the input switches, the output switch, and the 3 positions switch for the bypasses. So either position 1 would be the bypass on source 1, 0 would be on the output, and then position 2 would be bypass 2 for the source 2.
Yeah, it's interesting. The Q50 switch there, it is the 3 positions, so you can't accidentally switch it the wrong way and drop the load. What it does do is it monitors as well as you're turning it. So if you were trying to turn to source 2 bypass, but you accidentally switched over to source 1 bypass by mistake, the switch is monitored, and the static switch will perform a transfer before it goes into bypass. So you sort of got a bit of human error redundancy there, if you like.
Yeah. And another thing we can see on this one is you can see on this single light diagram you would get some fuses. So it's you can find 2 different options on the market. So without fuse and with fuses. It's a quite good actually alternative if you want to protect the SCR, or if you want to increase the K rating of your STS device, because they are high speed fast fuses. It means that they would blow very quickly. Now let's have a look at the OEM chassis mountable version. So as you can see, it's a proper chassis actually that needs to be integrated within a proper panel. So we would sell these units to panel manufacturers, and then they would incorporate this into PDUs or into proper panel. So as you can see here, it's this device is the highlighted green bit on this diagram. So basically, it's purely the STS device with all the components that needs to do the job for switching, monitoring, and everything around this. All the switchgear around this device, again, is to be provided from the panel manufacturer, and they would incorporate this into the panel. Again, here's the example with the single light diagram. So as we can see, the green bit here is the system we provide, so the STS chassis mountable we provide, and then we provide the diagram to the panel manufacturer, and they know what to do with the switches to incorporate them, and also with the bypass switch. So as we can see here, it will be an example of this chassis mountable device fitted within a PDU. So as you can see, you've got this chassis mountable behind this door. So we can see it here. On the front door, very important, we've got the touchscreen panel that we provide with the unit along with the detachable COM slot. And as you can see inside the PDU, so you've got the chassis mountable here, the touchscreen panel on the front door, as we said, and the detachable COM slot internally.
And behind the other closed doors will be obviously the switches for the 2 inputs and the output. And it's quite important that we monitor everything. So we monitor the Q50, our Q30 and our inputs, and we can flip the logic as well from normally open to normally closed within the software. So if if you're integrating it into an older panel and you've only got a normally closed signal, we can take that and we can still work with it, so it's completely fine.
Perfect. So that's it. I hope it's more understandable for you guys for the 3-pole, 4-pole, cabinet, OEM version. If you've got any questions, we are here to answer them. So please type them in the chat box if you haven't yet, and we can understand them. Have we got any questions, Terry?
We've had a few coming from our different sources. So we've got here one. Would the transfer time be longer with a 4-pole than a 3-pole switching?
Right. So no, it wouldn't. It would be exactly the same. On the 3-pole switching, we switch the 3 phases. On the 4-pole switching, we switch the 3 phases and the neutral. Just something we need to keep in mind, and we've covered that in the previous STS live stream. The neutral will be overlapped to keep the earth and neutral reference, but the switching time will be exactly the same. So typically 3 to 5 milliseconds. Unsynchronized transfer, we would say around 10 milliseconds,
12, yeah.
And still below the 20 milliseconds specified in the IT-IC curve.
Yeah, well, good answer, good answer.
Thank you.
And this one, if somebody's got a 4-wire, 3-pole version, but they've got no neutral on the incoming, would that work? And I think we touched on this very early on, and they are built differently, and the inputs for the power supplies especially, things for the fans and things are all wired slightly differently depending on whether you've got a 3-wire, 4-wire system. So no, initially we would need to know exactly what kind of infrastructure you've got to make sure we've got the right STS for you from the get-go.
Nice one. Yeah.
And I can't
any other questions?
See any others. There's a few people sharing it about, but there's none others that have come in. And those. We've got one about communication products. I mean, it's not something we touched on. There are communication slots, but again, all the 4-wire and 3-wire, they're all exactly the same communication slot, so we can have all the typical communication devices, Modbus, ADC, NetVision, SNMTP and stuff, and BACnet. So they're common across. But if you do need any more information, I'm sure Kevin will be happy to provide you with everything there.
100%. Always. So guys, if you have any further questions, please send them into our info box, so info.uk@socomec.com. So we really hope you've enjoyed this live stream. Please stay tuned on our LinkedIn social medias, because our next live session will be on the 7th of April. So it will be around the data center environment, so regarding the energy transition. So it's really important at the moment to understand that. It's basically how you can improve a sustainable future for your data center, old or new. So it will be presented from Colin Dean, our managing director, and Richard Govier, our technical director. And we really hope to see you next week at Data Center World. Yeah. Thank you very much. See you soon.
Goodbye.
Bye.